So welcome to a talk at Surge 2015 about something that happened during Surge 2014. Who was here last year? Raise your hands. Who remembers the guy sitting in the expo booth looking exactly like me all night? Yeah, I guess not. Yeah, well, yeah, nobody was there. So why would you remember it? It was just me. So this is a story about me, Mike Panchenko, CTO of Opsmatic, otherwise known as Pancakes to most people because people don't like pronouncing my name, which is fine, about what happened to me last year. So just a little bit about me. I am obsessed with complex systems and what that means for people interacting with those systems, especially databases. I'm a big believer in what I call lowercase DevOps, so not the stuff people slap on their job descriptions and marketing material, but what that's actually supposed to mean to an organization and the way individuals interact with and within that organizations and with each other. Those, the obsession with complex systems and DevOps is basically what got me into this so-called kerfuffle. And as I said, I missed a lot of the conference last year because something terrible happened. Now, this would be a really terrible talk if I just told you a story because you can go read the story, you can, it would be like 15 minutes long. So there's a bit of kind of themes woven in that I think tie this talk to the theme of the conference in general and this year as well, with the human factors keynote. The thing that no matter how many years I stay in this industry and come to Surge and work on databases and weird complex systems, the thing that hasn't changed is that it's really hard. Computers are really hard for people to continuously wrap their minds around, especially when a lot of people are involved. Automating computers is even harder because now you've got computers making other computers do stuff. And the reason all of this stuff is hard is because there's coupling within those systems. No matter how hard you try, there are going to be things and interactions that you cannot anticipate. It's just not humanly possible to anticipate all of the full depth of the stack on top of which you're running, especially now as we're moving more and more and more and more into clouds controlled by people that we don't even know. And as you'll see throughout the talk, this thing happened to us even in spite of being very cognizant of the possibility of a complex systems failure and setting up our infrastructure in a way that theoretically should have been resilient to such a failure. So the last bullet point is no matter how hard you try, you're going to miss something and it's going to be dumb. By the way, this is a really dumb story. Just heads up. So, when it happened, it wasn't a surprise at all because, like I said, for years I'd been reading all this literature and going to. Who here has been to a talk about lessons from aviation for web ops? Right? I've given one of those talks. You hear about it all the time. And the only thing you learn over the years is that it's just going to keep happening. So I actually gave a talk that referenced normal accidents quite a bit. No, this is the book on the previous slide. In 2011 at this very conference. And there's video of it in which I don't sound as dumb as I would have expected 4 years ago. And also observe the change of wardrobe. I used to wear nice shirts to talks, and now it's company shirt and dad shoes. So standards have slipped. Another fun fact that while we're telling stories, that I now find hilarious and worth sharing is that I grew that beard on purpose for Surge because I looked at the list of speakers and realized I was so far the youngest person there that there's no way anyone was going to take me seriously unless I looked older. Which now, being almost 30, I find absolutely middle school level thinking, but whatever. Hopefully it worked. Anyway, and I swear the puppy on a skateboard made sense in context. So the kind of going back to the roots of all our problems is that automation, if automation was only used by other robots, it would be fine because robots are really good about understanding inputs and outputs. I think that's all computers really understand is you put A in, B comes out, cool. Humans, when faced with many systems with many inputs and many systems with many outputs and things, those systems being linked, are not only unable to, even if they're able to fully grasp what's happening. They can't share it in a perfect way. Documentation always sucks or isn't there. Interfaces are not always intuitive and frequently aren't. So when it says do thing X, what's really happening is do thing X and Y and Z, or maybe just Y. Naming is still really hard, as the common joke goes. And these gaps in shared understanding is what leads to failure. And I'm still just setting up for, this is all foreshadowing. And the one thing I really want to stress before we get into it is that this isn't really about any one particular piece of software. What I don't want, we're going to name some of the things we were using at the time that had bugs and caused problems. It's not about that system or really any system. Someone's going to walk out of this room and say, oh, well, if they had used Docker or whatever, some other hot new thing, this would have never happened. And that would be, if a person walks out of this room thinking that, then I've done a poor job, because the whole point, I think, is that any software of sufficient complexity is going to result in interactions like this. And in fact, the easier a thing becomes by use of a system, the higher the potential for that system to have a completely catastrophic failure, because just more stuff is buried under the ground. Everyone here has sat on a self-flushing toilet and had it flush at the most unfortunate of times. It permeates our whole life, right? But closer to the heart, someone needs to talk Joe D'Amato off a cliff right now. Hopefully his friends are near him, because he just straight up has decided that infrastructure as code is impossible because nothing works, and he gave this talk at Automacon, I still can't say it right, where he basically described all of the low-level bugs that you're sitting on top of when you're just, you're doing something simple like converging a node with Puppet, right? And in the meantime, somewhere deep in the assembly, problems lurk. So I've being a philosophy major, I've kind of taken on a sort of existential approach to all this, where, computers are just going to keep being terrible, and the best thing we can do is be prepared. But anyway, that's enough philosophizing. Here's why I missed Surge last year. One last thing to keep in mind, this is a year-old story, so a lot of stuff has changed, both about the software involved and about our infrastructure, but it's told as it happened. So, as we know, Amazon is really, really good at giving Surge attendees something to talk about. This year, they had a DynamoDB outage just in time, this past weekend, and if anybody says control plane during the Q&A, I'm going to lose it. In fact, I think if I hear control plane uttered in the hallway one more time, I'm going to lose it. And last year's version was what we called Rebootorama. I think there were many other clever names for it. But basically, everyone got this notification, all AWS users, that said, some portion of your fleet is going to be rebooted at these rigid, predefined times. Good luck. And what had happened was, AWS is a virtual hosting provider, so you're running virtual instances on top of physical machines using software called a hypervisor. And when you need to upgrade the hypervisor, you need to restart all the machines running on top of it. And that's just what they needed to do. Again, it's been a year, so let me remind you, there was a security vulnerability with the Zen software. And so they had to, all their hypervisors running an earlier version needed to be restarted, so everything running on top of them needed to be restarted. And the most unfortunate thing from our perspective when we were sort of absorbing these news was that you couldn't pick the window. It was just, here are the windows during which these servers will be restarted. Now, anyone, including myself, that watched my own talk from 2011 would have been well prepared for this, because everything would have been horizontally scaled. You would have had more than one copy of everything running. No big deal, right? And for the most part, we were. The only real kind of problem we had was that we hadn't really done, like that many reboots. Like not everything was quite perfect, right? Like everything was auto-healing and horizontally scalable, but it was still going to cause some interruption if it just kind of happened on its own without any intervention. And mind you, we were in beta. We had customers. The stakes weren't that high, right? Like the Apollo lander didn't crash because Opsmatic's infrastructure wasn't perfectly resilient. So we had invested appropriately. But for the most part, we weren't really worried about this. The one thing we decided to do was deal with it during business hours, because the windows were all set to be at like 5 a.m. Pacific or something, where all our engineers reside. And so if we wanted to avoid being at Amazon's mercy for the window, we had some options. And the options were terminate and replace the window, the instances, because when you created a new instance, Amazon was smart enough to put it on a already patched hypervisor, so you wouldn't need to reboot it later. You could also perform a stop-start, which specifically in AWS is very similar to terminating an instance, except you get to keep the root partition and just assign it to a new instance on some other hypervisor. And the only thing you lose are what are called ephemeral disks, which I didn't really understand the name until just then. The ephemeral disks are the main storage capacity of most instances. You know, your root partition is usually like 10 gigs, and then different instance sizes have 1 or 2, 40 or 80 or 320 gig partitions, or sorry, drives, which you get to use for your, say, database storage. Now, the reason they're called ephemeral is because they're attached to the hypervisor in which you're running. So if you stop an instance and start it up, it'll get started up on a different hypervisor with different ephemeral disks. And the other ephemeral disks will be lost forever. So with all that in mind, we looked at the nodes that were going to be rebooted. And there were 3 sort of types of nodes. There was one NAT node. And these are very simple nodes that are just running, I think like DNS Masquerade or something. It's basically, they're basically just forwarding nodes. They're running, at the time they ran DNS for us, which we got rid of, thank the Lord, eventually. But at the time they still were. And they were serving basically as the forwarders for any outbound traffic from our internal network to the rest of the world. So they were very simple, very stateless, and they were deployed using a very dumb transactional script, which was different from everything else because they had different networking requirements, and it was easier to just do that than make, again, foreshadowing, make Chef Metal work with that. Everything else, including the other 5 nodes that were to be rebooted, was provisioned using a tool called Chef Metal, which is now known as Chef Provisioning. And what that is a extension of Chef that lets you declare not just what's going to be on an individual server, but what your actual infrastructure should be. So you would say, oh, I want 2 nodes running the stack role, which is basically where all our services run. I want 10 nodes running Cassandra. And when you ran it, it would say, oh, well, you only have 5 Cassandra nodes. Let's spin up 5 more. So it's basically a way to declare the state of your infrastructure and let Chef converge the state of that infrastructure. It's similar to, I believe, a tool called Terraform, which is gaining popularity as well recently. So we, unbeknownst to me, were very, very, very early adapters of Chef Metal. Someone showed me this thing, and I was like, well, it sounds great. I didn't really vet it super carefully, but it turns out, again, foreshadowing, it was very early days for Chef Metal. So the plan we came up with was, for the stateless nodes, just stop and start them. We don't care that we lose the ephemeral storage. There's nothing there. And we briefly debated actually replacing the Cassandra nodes, but the timing we were so close to the window already that we weren't sure, it takes time to remove a node, copy the data, add the node, et cetera. It's sort of a risky and high intervention, time-consuming process. And Cassandra is supposed to be able to withstand a restart anyway, right? Like the whole point of running a database like Cassandra is that you should be able to stop, restart, move, and whatever nodes at your pleasure. So what we decided to do is I was just going to wake up at the beginning of the window, because I was already on the East Coast at Surge, and I was just going to gracefully stop the database daemon just out of an overabundance of caution, even though probably it would have been fine if I hadn't. So we started going about this plan. I'm over in the expo booth during lunch, tapping away. And the first step, no problem, right? We stop the instance. We fail over to the other NAT node. We stop the instance. I actually have the Slack logs from when we were doing this. We failed over to NAT 02, stopped NAT 01. You can see the graph with the, I don't know if you can you see the network traffic moving over to the other node? I like to illustrate what's happening as I'm doing it. So no problems there. By the way, if you don't know what but.holdings is, paste this into everything before you do anything important. It's one of the best uses of a GTLD I've ever seen. It's just a GIF of Samuel L. Jackson saying, hold on to your butts. Anyway, So then I went about to the actual stack nodes. And again, the stack nodes, our infrastructure was pretty simple at the time. We had a bunch of different little services running, but because we were doing very little traffic, they were all running on the same physical nodes, right? There was no point in spinning up a giant fleet. We just had a chef roll that was kind of fat. And so that's where all our actual software was running. All our software is stateless because it relies on various databases, so it should have been very simple. Just stop the instance, start the instance, done. Same as the NAT node, except I'm a person, so I'm terrible. We were only using 2 stack nodes, but we had 4 because we provisioned 2 more just to test some new software. And today, what we would have done is we would have created a copy of the stack roll with the same software on it and treated that as a completely separate cluster. Back then, we weren't so well organized and smart, so we just had 4 stack nodes, and they kept, as I was kind of running various scripts across the stack cluster, I kept noticing that I'm running it on 4 nodes instead of 2, being like, you know what, this is starting to get dangerous. I'm gonna accidentally put these nodes in production, so I'm just gonna go terminate them. And then I literally did like an old person at a computer thing where I meant to check stack 03 and stack 04, but somehow also had stack 02 already checked. So when I went to terminate them and I clicked confirm, as my finger was lifting off the mouse, I was like, oh no, it's 3 nodes, why is it 3 nodes? Again, no big deal because we have 2, right? All the traffic failed over to stack 01. Stack 02 got removed from the load balancer. All great. Actually pretty proud that it even worked that well at the time. Again, we were still in beta. And then I thought, well, everything's still fine. Yeah, I accidentally killed an instance, but we're set up for this. All I got to do is run chef metal. Chef metal says we should have 2 stack nodes. It'll make it so. And everything will be great again, right? Who thinks this went well? So I ran chef metal, and this is the chat log. So I say I'm going to destroy stack 03 and stack 04. I neglect to mention to my peers that I also destroyed stack 02 because I think, well, this is embarrassing, but it's fine. I'll just run chef metal, and everything will be like it was. And then I kind of start seeing weird things where I'm looking. Everybody else starts noticing the alerts going off in the alert Slack channel. And then we, within a minute or so, arrived at the conclusion that production is just down. Like, all of Opsmatic is just gone. And this is the PagerDuty graph from that day, and I still think this might be the highest peak of all time, because literally everything paged. Every check we had in our system was just like, whoa, there's no more infrastructure. Literally everything got rebooted. Every single instance that ran a database or a service or a queue in our infrastructure got rebooted at pretty much the exact same time. So if you want to talk about a game day, try rebooting your whole infrastructure at once. And I call myself the CTO army. All right? You don't need Chaos Monkey and the Simian army. You just need your CTO at a computer. So as I was scrambling around, like, what the hell? What did I just do? It was very clearly related to what I had done. I saw this log line repeated over and over and over and over again. I've starred out things that might be or might not be sensitive, whatever. So it says, this instance was started, but SSH did not come up, rebooting machine in an attempt to unstick it to everything. So as we dug a little deeper, why couldn't chef metal SSH to these machines? Well, very simple, pancakes. The Ubuntu user is missing, and chef metal is configured to use the Ubuntu user to log in. And anyone that's run Ubuntu and AWS knows that that's the user that gets put on the machine when you provision stuff. We extracted the provisioning key that we used for that and configured chef metal to use the same thing. A terrible pattern, if you ask me, by the way. Having like a user with a private key that everyone has access to for running commands. Turns out I thought that this was terrible back when we first bootstrapped our AWS infrastructure, long before we were using chef metal. And I had a little chef recipe in our chef repo called remove default users. And very clearly, a couple weeks before all this happened, our own tool told us, once we were like, how did this happen? Why is the user gone? That recipe got applied across our whole infrastructure. But it very obviously shouldn't have, because we had just moved to chef metal. We knew we needed the Ubuntu user. And when we looked at the run list now, right after the outage, it was no longer there either. So We didn't yet have the tools to tell us, because Appsmatic was brand new and didn't yet answer this question, when it was added and removed from run list, but we knew that we had the general time bounds. But where did that come from, right? So like I said, so I kind of jumped ahead a little bit, right? So we had deliberately nuked it before we used chef metal. Then I begrudgingly agreed to say, fine, let's keep it around so that chef metal works. And then something, or obviously someone, added it to the run list long enough for it to run and nuke the user, and then it was, at some point, removed again, right? Who knows? Antecedent number 2 was a bug in chef metal, which also was very clearly discovered once we got into the chef channel and said, hey, is this normal? Does everyone do this? Does everyone just really like to party and restart their whole infrastructure that uses chef metal? And it turned out that no, it was only supposed to do that during the first 10 minutes of a node's lifetime. So hosts that had existed for weeks and weeks and weeks, like the rest of our hosts, should have never been rebooted, but here's a bug. And again, like I said earlier, not bagging on chef metal, everything has bugs. We just happen to find our own perfect bug for our own perfect scenario. So, it took us about 30 minutes to get everything back up, because not everything was as automated as we had thought. Like certain services didn't get started up by chef when the machines booted back up. And then there was sort of order of operations where things tried to start up, but something else wasn't running, so they failed and then didn't start. And then, as we worked through the list of alerts that were still red, we basically got everything back up and running. I ended up, this is me in the expo booth just out there. You can't probably tell very well on the projector. It is dark outside. Everyone's gone. At some point, a security guard came by and said, you supposed to be here? And I had to explain that, like, yes, I was here for the, here, where's my badge? I'm supposed to be here, it's fine. But like, it really made me realize that I needed to wrap it up because everyone else was out drinking already. But I was still sitting there going, seriously, how did this happen, right? How can we figure out, because if it happened once, it's gonna happen again, right? We have no answers for how we got here. And so what became very clear was that that recipe was no longer needed, ever, so it shouldn't have even been in the chef repo, and there was no reason not to delete it. And one thing that deleting it would give us is the next time it happened, there would be an error right then, which would allow us kind of a fresher crime scene as opposed to being like, well, sometime in August, someone did this, don't know. So at this point is a good place to kind of jump off and talk a little bit about mode confusion. To set up the big reveal for what actually happened, because we did eventually figure it out. So mode confusion, the only definition I could find that was succinct was in a paper about airplanes, because of course. So mode confusion occurs when the flight crew believes they are in a mode different than the one they're actually in, and consequently make inappropriate requests or responses to the automation. That paper is from 2003, but the concept predates it by quite a bit. It was just the most succinct capture I could find. And here we go, talking about airplanes again. I swore I never would, and here I am. Fortunately, you can also explain this in terms of a toaster. When your toaster is set to broil, but you think it's set to toast, and you put a piece of bread in there, and who knows what happens, right? Like, the inputs and outputs are not what you think they're gonna be, because there's you're not in the mode you think you're in. More recently, this is the thing that got beaten to death, right? The more recent Air France crash. The pilots didn't understand anything that was being shouted at them by the monitoring systems of the airplane, because they thought they were descending when really they were climbing, right? So they were not in the mode they thought they were in. More close to our hearts, since I often lament the excessive references to fields that aren't just playing computers. In 2014, not to be named service provider had an outage where someone was performing routine maintenance in the only data center they had where they had more than one brand of switches. And they performed the operation on all of the switches the same way, and it worked fine on one brand, but had a very, very, very negative consequence on the other. And the mode here was, which switch am I actually dealing with, and remembering that they actually do different things. And then even more recently than that, the CTO of Appsmatic forgot that chef roles and chef cookbooks behave differently when you upload them. And that, because base and base original are actually referring to the same role, trampled some stuff. So when you do knife cookbook upload foo, it looks in cookbook/foo and uploads that. When you upload a role, you have to give it the file, and then it determines where to store, like what the label of this thing and how it's going to be recalled, using something that's in the file as opposed to just the name. So if you looked at roles base and roles base original, they're actually the same role. Now, how did we get to base and base original, right? So we had this role that was basically its only purpose was to be included in other roles, and it configured sort of the bare minimum Appsmatic infrastructure, monitoring, collect D, whatever else you put on every single node, the users, SSH keys and stuff like that. At some point, someone went to refactor it, created a copy of it to kind of have up as they moved stuff around to make sure they didn't forget anything, and then mistakenly committed the original file to Git along with the modified file. I came along, and I interpreted that to mean that base original was still being used by some, we were not done with the migration. And so if I wanted to add something, I had to add it to both. I don't remember what I was adding at this point, but I added it to both run lists and diligently said knife role upload roles base and knife roles upload base original. And as far as I could tell, everything worked because all the nodes got the addition that I was looking to achieve, because the actual difference between base and base original was not huge, except crucially, base original still had the remove default users recipe in it. Things stayed in that state just long enough for Chef to run, well, actually longer than that, run everywhere and delete the Ubuntu user. Then, sometime later, I'm kind of lagging behind, right? So sometime later, someone that wasn't confused came along, modified base.json, and only uploaded that, which then removed the recipe from the run list, which is the state we found it in. I told you it was a dumb story. So because this role was included in every single other role, it got rolled out to every single host in our infrastructure, and the Ubuntu user got deleted everywhere. So the chronology of this confusing, dumb story is, I think, very interesting. Oh, it's cut off. So you guys haven't been seeing the title of any slide. Well, good thing that's not that important. All right, so we started using Chef Metal sometime in mid-July, and that's around the time we, there we go. We started removing the fatal recipe from our infrastructure. In late August, I made my fateful change without knowing how things worked. Why is it taking 2 clicks to go? OK, well, anyway. So someone who wasn't confused fixed it, not knowing they were fixing anything, a little bit later, in early September. And then while I was at Surge, I actually ran Chef Metal and destroyed our world. Immediately thereafter, we deleted the recipe that caused the problem, so the next time we encountered the same issue, the same sort of Heisenbug, we would have a clearer idea of what had caused it. And it wasn't until October 14th that I made the same mistake again, and immediately Chef blew up, and I was like, oh, wait, it happened again. What did I just do? And then I waved my arms and said, look, it happened again. And then at that point, the person that knew how roles worked and was cognizant of it was like, wait, did you just upload base original? Why did you do that? And I was like, well, because it's there. I had to add something, so I added it to both. And then we figured it out. But that took a full 3 months, right? So from going back to kind of the introduction, right? Like the full chain of events took a full 3 months to unfold. How can no individual person did anything super wrong? I mean, I obviously misunderstood how roles worked, but in my defense, I think it's to be expected that someone is going to make that error at some point, right? When you have two things that you upload, but the way it behaves is different, someone's going to forget. But over these 3 months, I did sit next to a pilot at a wedding recently and talked to him about complex system failures. And he said, oh, yeah, we talk about breaking the chain all the time. And what that means is opportunities to have avoided the terrible catastrophe, right? So whoever refactored the base role could have just deleted base original and not uploaded it to Git. Never would have had the issue. I could have remembered that base and base original refer to the same thing, and I shouldn't be uploading base original, or at least, certainly not uploading it last. Chef Metal could have not had that bug right at that time, or could have fixed it just before. And I think actually, they fixed it immediately after this. I could have not accidentally terminated the node that I was supposed to stop-start. Although, of course, asterisk, then this would have just happened sometime later, and maybe been less comical. But anyway, so the lessons we took away from this, again, the only thing you can really do is try to set up your infrastructure in a way that avoids these sorts of pitfalls. Make it easy to do the right thing. One thing you can do that's, if you're a Chef user in the crowd and you're using roles, stop it and start using role cookbooks, which are functionally identical. They're just cookbooks that list a bunch of recipes, but otherwise behave like cookbooks. So you upload them the same way, you manage them the same way. They're actually versioned, which is really nice. Roles aren't. And it makes it much easier to actually test. Right? So now, whenever you make a change to a role, you run Test Kitchen, and there's tests associated with it that make sure that certain things are true about a host. And so this sort of thing would have theoretically been caught by one of these tests. Would it really have been? I don't know. That's a counterfactual, right? The other takeaway is finish big, and really any sort of migration or change or kind of sweeping change in your infrastructure as quickly as possible. Because, right, like the very, 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 very first antecedent is super dumb, right? Like someone went to make a bunch of changes, and instead of just finishing all at once, they left this cruft behind. And my expectation was that if base original is there, right, that we were in the middle of something. So I was kind of primed to poorly understand what was happening. Now, of course, this is process related, and anything that involves process is incredibly difficult to anticipate, right? Like every time you have one of these bugs, you say, oh, okay, well, we're going to do X, Y, and Z differently, but it's not that you're done then, right? You're just going to have a different failure that you're not anticipating. And the last thing is just mind the interactions, right? So the question I immediately asked the next day when we were talking about sort of remediations for this is it desirable, even in the absence of bugs, that in order for me to spin up a single node, Chef Metal has to go touch every single one of my other nodes? Now, is that an inherent property of Chef Metal? I actually don't know. It might be that you could set it up so that it was more segmented. But in our case, that's the way it was. And I said, look, if we're trying to avoid coupling, definitely don't want something like that in there, right? Where in order to do one simple thing on a brand new host, I have to touch all of my databases, right? And risk that this sort of bug is happening. That we hit a bug like that. But in the end, all you can do, as we get older and better, certainly as I get older and better, or hopefully better, you learn to set things up to avoid the catastrophes. And like I said, the actual really blatant human error that happened where I clicked on the wrong thing resulted in nothing, right? The node died, traffic went somewhere else, nobody cared. It's the hidden stuff that happens that you don't really anticipate. Anyway, as I told you, it was a really dumb story. I ended up with a whole ton of time left, so I can tell you another really dumb story about Chef. But you might actually fall asleep. So I guess I'll just wrap early and open up for Q&A. And here's how you can reach me if you have any questions. I wrote a blog post about this, which is a little more factual and less windy than this if people want to kind of understand what happened a bit better. And of course, as everybody else, we are hiring. So hit us up. Anyway, are there any questions? What's up? Oh, perfectly. In fact, I probably could have just stayed in bed. Yeah, so what ended up happening there is, like I said, that's why I wrapped up so fast. We probably didn't need to do anything there, right? Because the whole point is, we write everything at quorum, which means in our case at least 2 nodes. None of the nodes were set to restart at the same time. So even if the node just died, right, the data had already been written somewhere else. Because I am a cautious person that doesn't trust computers, I woke up 5 minutes before the window and logged on and said, service Cassandra stop. And then the nodes got rebooted, came back, data got replayed, everything was totally fine, which is, really rewarding because going in as a small startup and making the investment to put your data in a database like that is often hard to justify, but that was a very visible example of like, look, it did exactly what it was supposed to do. I didn't have to like do any weird manual failover or like the software just did the job. That was awesome.